You know that plastic bottle you toss in the recycling bin? Ever just see it as, well, trash? What if I told you that same bottle could be the key to your next big idea, maybe even your next invention? Okay, let's really get into this because today we are exploring the absolutely incredible process of turning a huge disposal problem into a manufacturing solution. We're talking about turning everyday plastic waste into valuable filament for 3D printers.
So, to really get why this is such a big deal, you have to understand the scale of the problem. Just look at this number. By 2015, humanity had already cranked out 7.8 billion tons of plastic. I mean, to put that into perspective, that's more than a ton for every single person on the planet. And the craziest part, more than half of it, about 55%, was just discarded, thrown away.
And this is the question that just changes everything, right? Instead of seeing this gigantic mountain of waste, innovators are starting to see a mountain of raw material. And that simple shift in how we look at it is the foundation for a totally revolutionary new approach.
And that approach, well, it has a name: the circular economy. This is a completely different way of thinking about how we make stuff and how we use it. It's a system designed to eliminate waste right from the very beginning.
The big idea here is to just break our current take, make, and dispose habit. Think of it more like a library, but for materials. You know, instead of throwing a book away after you read it once, it goes back into the system so it can be used over and over again. In a circular economy, every single product is designed with its next life already built into the plan.
So plastic recycling isn't just one thing. This slide breaks it down really nicely. You've got primary recycling, that's simple. A bottle becomes another bottle. Then you've got tertiary, which is super complex, using chemicals to break plastic all the way down to its basic building blocks. But for what we're talking about today, the real magic happens right in the middle: secondary recycling. That's where we get to transform old products into something brand new.
Yeah, secondary recycling, sometimes called downcycling, is the absolute key here. It takes that polymer waste, like a PET bottle, and processes it into something totally new, like 3D printer filament. Now, the properties might change a little, but the point is it's been given a whole new purpose and, more importantly, a whole new value.
And this visual just illustrates the difference perfectly. Over on the left, you see a closed loop. Bottle becomes bottle, end of story. But on the right, that's the open loop. That's where our waste PET bottles get collected, processed, and completely transformed into new products. See, it's not just recycling, it's total reinvention.
So, how does this reinvention actually work? I mean, how do you really get from a crushed-up bottle to a perfect, precise spool of filament? Well, let's walk through this step-by-step recipe.
This flowchart gives us a fantastic bird's eye view. We're going to follow this whole process together, from a pile of plastic bits and pieces all the way to a fully tested, ready-to-print filament. It really is a journey of careful transformation.
Okay, so that journey breaks down into 4 main stages. First, we've got to select and prep the plastic. Then, we test how it flows when it's melted. After that, we actually extrude it into filament. And finally, of course, we do quality control to make sure it's good to go.
Step 1 is all about getting your raw materials just right. You start with a specific type of plastic, like ABS or the PET from our water bottles. It has to be cleaned, really cleaned, then completely dried to get rid of any moisture, and finally ground down into these little uniform pellets or granules. It's a classic case of quality in equals quality out.
Now, before you can turn those granules into filament, you have to know how they're going to behave when they get hot. And that is where the Melt Flow Index, or MFI, comes in. This test is absolutely critical. It tells you if the plastic is going to flow smoothly and consistently through that tiny little 3D printer nozzle. If you get this wrong, your print is pretty much guaranteed to fail.
And just look at this. This isn't guesswork, it's pure science. This table shows how adding different recycled materials, like iron powder or even wood dust, actually changes the MFI of recycled ABS plastic. So engineers can fine-tune these recipes to get the exact flow properties they need for perfect filament. Pretty cool, right?
So once the material passes that all-important MFI test, it is time for the main event: extrusion. The granules get fed into a machine, usually something like a twin-screw extruder. And inside, it's heated up, melted down, and pushed through a tiny nozzle, and it comes out as this long, continuous string of filament, which is then cooled and spooled up.
Okay, so this all sounds amazing, but we have to be realistic here. This process isn't exactly a walk in the park. Turning messy, inconsistent waste into a high-precision material, well, it's tough.
So here are the main hurdles you're up against. Every single time you melt and reform plastic, its molecular chains can break down a bit, making it weaker. Any little impurities that are left over can cause clogs or weak spots in the final filament.
the waste itself isn't consistent, and, of course, the initial cost for the shredders, dryers, and precision extruders, that could be a pretty significant investment. So if there are all these hurdles, why bother? Why push through? Because the payoff, for our planet and for our economy, is absolutely enormous. This is really where we see those challenges turn into some seriously powerful opportunities.
On the one hand, the environmental wins are just so clear. Less plastic piling up in landfills, less need for fossil fuels to make brand new plastic, and a real working circular system. And then, on the other hand, the economics are just as compelling. We are literally turning a disposal cost into a manufacturing asset, we're empowering people to create things locally for cheap, and we're sparking entirely new business models.
So the next time you toss a bottle into the recycling, I want you to think about this journey. That little piece of trash actually holds the potential for real innovation. With these technologies, the answer to the question you see on your screen is quickly becoming a resounding yes. The future of manufacturing might just be sitting right there in your recycling bin.